All right, so 5.2 number 14. So what we're doing is we're identifying important aspects of the graph, and then we're going to put it together. It looks like to make a, no, don't wait. Oh, I guess we don't have to come up with an equation for this one. Oh, whatever. Oh, yeah, we do. For each states. All right, amplitude. Amplitude is easy. Take the maximum value, which is 3, the minimum value, which is -3. Find the difference between those. So 3 minus -3 is 6, divided by 2 is 3. Now, if you're sure that this is the midline, if you're absolutely sure this is the midline, you can just count up from the midline 3 units. But if it's not super clear, you have to be careful. So if this was like 3 and this was like -2.7 or something, you can't just assume that you know what I mean? You have to actually make sure that it's the half of the total range there. Half of the range is A. So amplitude here is 3. Okay, the period. So from the beginning of the cycle to the beginning of the next cycle, you can pick anywhere. You can pick 2 crests or maximum points. You can pick 2 minimum points. You can also, if you can pick like this point here that's at 0 right here, and you can go straight across until this spot right here. Well, that's only half of it, isn't it? So it wouldn't be on here, but that's half of the period. You see? The whole period would go up and then down and back up again. So this is only one half. It's only one hump. It's got to have the 2. So you'd have to go. Go to. So yeah, this is why it's tricky. Watch this. So you got to go from here to here. That would be the full period length. Because the graph is going up here and the graph is going up here. So not this one, but this one over here. Yeah. If you don't like that, then just pick this point and pick this point and then find the difference between those two. But can you see that this is from, let me erase some of this stuff now. Okay, can you see that from here to here is 2 pi? You go 0 to 2 pi. Okay, so the period looks like it's 2 pi. Yeah. You could also go from here, the x-intercept, to the next x-intercept, starting the next wave. That's the easier one to see. See, there's a full wave there. So that's 2 pi. Okay, the phase shift. So for a sine graph, a sine function, how far over did we go here? Well, just to this point, right? So it's pi over 4. Good. Pi over 2, yeah, half of pi over 2 is pi over 4. Okay? Got it? All right, vertical displacement. So how high did we go? Did we have to move the original sine graph to get this one? Yeah, nothing. Yeah, because it's symmetrical about the x-axis there, so we didn't move it up or down. So the vertical displacement is 0. Domain and range. Okay. So domain, we haven't talked much about domain, but I'll write it down here. Domain for a sine or cosine graph, there's no restrictions on the variable. There's no asymptotes. There's no gaps. There's no discontinuities. Every point is filled in on the graph, and it goes forever to the left, forever to the right. So it's just x is an element of all real numbers. Okay? The range, though, is not the same, right? The range goes from -3 to +3. So -3 to +3. That's how you write that. That's set notation to write that. Sorry?
The domain for all sinusoidal functions are
Yep. Yeah, the domain for all sinusoidal functions is just xer. It's all real numbers. Everybody see this? -3 to +3?
Yep.
Okay. Awesome. So domain and range done. Maximum value of y and the values of x for which it occurs over the interval 0 to 2 pi.
Huh?
The maximum value of y and the values of x for which it occurs. So between 0 and 2 pi, the maximum value of y is 3. And what's the x value at which this occurs?
3 pi over 2.
1 pi over 4, 2 pi over 4, 3 pi over 4. You bet. So x is 3 pi over 4, and y is 3. You can write it as a point there if you want. Yeah, it's a bit of a funny question, but. And the minimum, same thing. So what's the minimum value of y, and which x does it occur at? Here's the minimum. That's going to be negative 3, right? And the x is, what's this x value right here? 1 pi over 4, 2 pi over 4, 3, 4, 5, 6, 7 pi over 4, right here. Well, if you know that each square, like that each distance here, this is pi over 4, right? Because this is pi over 2, so each square is pi over 4. So that's 1 pi over 4, 2 pi over 4, which simplifies to pi over 2, 3 pi over 4, 4 pi over 4, which simplifies to 1 pi, 5 pi over 4, 6 pi over 4, 7 pi over 4. Awesome. There's a light bulb. The room just got brighter over here. Boom. A light bulb went on. Okay, 7 pi over 4 and negative 3. Good. Now, the question doesn't ask for it, but let's do the function. Okay, sine function. Let's do the equation. So what is a then?
3. No. 3.
Yes.
A is 3. Good. What is b? 2 pi over b equals 2 pi over 1. B is 1. The phase shift is pi over 4. We're going to the right, so that's c is pi over 4. And d, we didn't have to move vertical displacement. D is 0. So this should be really easy. This is going to be y equals 3 sine of, and we don't need a secondary set of brackets. It's just going to x. Let's do x. Minus pi over 4. Good. Then plus 0, right? So that's it right there.
Couldn't we do like 3, if it was, say it was 2, couldn't we 2x minus pi over 4?
If what was 2?
If b.
Yeah, b was 2. You would have 2 bracket x minus pi over 4.
Oh, okay.
Yeah. And if you wanted to remove the brackets, you'd have to distribute the 2.
Into it.
Yeah.
It'll be 2x minus.
So it'd be 2x minus pi over 2. If b was 2. Okay, any question about 14a then? Yes, no, maybe so? Good. Thumbs up, 5 out of 5. What are we at, yeah? Okay. All right, it's 14. Okay, finish the rest of your assignment there. 5.2, parts 1 and 2, please.